Welcome to a new playlist of econometrics. Here we are going to discuss about different concepts of econometrics. Econometrics is little bit different from the concepts of economics. Although it is a very important aspect of economics, econometrics is basically a combination of economics, mathematics and statistics. If you want to get a very good grip on econometrics, then your statistics and mathematics must be in full control. Because without the help of statistics and mathematics, you won't be able to understand econometrics completely. Now, why is econometrics so important? Or what is the real demand of econometrics actually? To be honest, econometrics was not in much demand for a very huge time period. But in the current period, or we can say after 2010, econometrics has gained a very huge popularity in the field of statistics and economics. What is the purpose that econometrics solves? Well, econometrics is little bit different from the other subject of economics. Like if we talk about microeconomics, macroeconomics, development economics, public finance and all of that economic papers are basically designed on the basis of some theories and their mathematical proofs and derivations. But all of those theories are based on some certain assumptions which are very difficult to be made in real life. But if we talk about econometrics, econometrics is not that type of paper, or econometrics is not that type of subject. Econometrics has real life implications and applications which are much more realistic and much more appropriate. It can be observed in real life, and many different type of phenomena in real life we can explain by the help of econometrics and by the help of different concepts of econometrics. Well, here I am starting my class. Econometrics is basically a combination of economics, math and statistics. It is a tool for empirical verification or validation of economic theory. Well, suppose in economics we all know that as per the law of demand, keeping the other things constant or keeping the other factors constant, when price increases, demand will fall, and when price decreases, demand will increase. Well, this is very clear to us, right? But have you ever thought that how can you actually prove that? Suppose I want to check whether actually demand is increasing due to fall in the price, or whether actually demand is decreasing due to increase in the price. So for that I may do a very simple thing. I may collect some data on demand and price. Okay, and with the help of that data I may find out the y-intercept and slope. Okay, and the calculated slope, if it has a negative sign, then I can say that yes, the relationship between demand and price is negative, and if price increases, demand will decrease, and if price decreases, demand will increase. Right? But yet, think about it. For getting that evidence that really we have a negative relationship between demand and price, we have to calculate the value of the slope. Right? And for calculating the value of the slope, we need the help of econometrics. So that's where econometrics comes handy. Econometrics actually helps us to validate and verify the different perspectives of economic theories, whether those economic theories are properly holding in the real life scenario or not. You can take the example of supply, law of supply also. Law of supply tells us that if price increases, supply will increase, if price decreases, supply will decrease. Ceteris paribus, keeping the other thing constant. Right? But is it really holding? For that we may take some econometric applications. We can take a variable called quantity supplied, and we can take another variable called price of the commodity. Right? And if we do this thing, and if we from the given data, suppose you have multiple data that will be available with of price and supply, quantity supplied in that price. From that given data you can calculate the slope. If it is positive, then yes, law of supply is being held, or if it is negative, then law of supply is not being held, right? So let me move to the next topic, economic theory here, law of demand. That means demand and price are inversely related. Mathematical representation can be written here as demand equals to alpha plus beta p. Here demand is denoted by D, P is denoting the price, and alpha and beta are the parameters. Parameters are basically the terms which are used for definite values. That means alpha and beta has a definite value, but the value is not defined yet, and the value can differ in different models, right? I mean, in case of demand and in case of law of demand, in case of mathematical representation of law of demand, that is demand equals to alpha plus beta p, where p is price, which is given here also. In this model, alpha and beta has a definite value. Suppose alpha is 2 and beta is 0.5. In another model where we will try to explain the law of supply, right, in that model this value of alpha and beta will change, obviously, right? So this is the concept of parameters. That means the value is fixed, but the value is not assigned yet, but the value will differ in different models. The value in this model and the value in other model, the value of parameters in this model and the value of parameters in other model will not be same, right? Now statistical representation of this theory. Now this is numerical representation or mathematical representation of this theory, right? That demand depends upon price. But if you want to represent it mathematically, this is mathematical representation, but if you want to represent it statistically, then what will be the statistical representation of this theory? Well, to be very precise, statistics is a very interesting field. When you are dealing with economics, you are saying that demand only depends upon price and there are no other factors that can influence demand, right? But when you are dealing in real life scenario, then you can't keep the other factors constant. What are the other factors? Like income of a consumer, which also affects demand, right? Price of related commodity, that also affects the demand, right? So there are many other factors which can impact or which can influence demand, but these factors are not included in the model. In the case of economic model, we don't include these factors, but in case of statistics or by the help of statistics, we are including all of these factors in the model. But now just think about it. Do you know all the values or do you know all the variables that can influence demand? What can be the variables that can influence demand? Someone will say that income of the consumer influences demand. Well, true, but is income of the consumer the only factor that can influence demand? Obviously not. There might be thousands of other factors that can influence demand. So it is not possible for us to consider all the other factors or all the other variables in the model, right? So for that, what we are doing here, we are taking a term which is called UI. Here UI is taken because UI is going to fill the lack of all the other variables which can affect demand. As I have said here, that price is not the only factor that can affect demand. There are other 1,000 factors that can affect the demand, right? So we are not going to take the 1,000 factors one by one, and it is not always possible for us to find out all the other 1,000 factors that can affect demand. So in the place of all the 1,000 other variables that can affect demand, we are taking a single term UI, which is going to represent all the 1,000 other factors that can affect demand. And UI is nothing but, it is called error term, which can be included due to statistics. We are being able to include UI because of statistics. Okay. Now here there are multiple names of the variables. As you can see, demand is depending upon price and obviously some other factors which is denoted by UI. Now here demand is what? Demand is a dependent variable. Demand is depending upon what? It is depending upon price, right? And price is what? Price is an independent variable. So we have given, there are other names also. There are other names of dependent and independent variable also. So here demand can be a dependent variable, and there are other names also. What can be the other names? Demand can be termed as explained variable, it can be termed as regression, it can be termed as predetermined. Price is an independent variable, it can be also termed as explanatory variable, and it can be also termed as regressor. Okay, so these are the different names of the independent and dependent variables. Now, so we are going to know different things or very important things about the different parts, right? Now, the variable that we have included, or the term that we have included to cover all the other variables that can influence demand, or basically what we are doing here, just take the example here. Here this dependent variable y is not only depending on x, there are thousands of other factors or other variables that is affecting y. So we are not taking those 1,000 other variables in our model, we are just taking ey, and ey is going to represent all the 1,000 other factors which is capable of affecting the dependent variable called yi. Now ui is a random variable, ui is a error variable. What is a random variable? Random variable is a variable in which there is, you can't say that it can have a definite value. You can't say that it can have a definite value. Random variable is a variable in which there is a probability for each value. Like if I give an example that x plus 5 equals to 9. Now you can say that from this equation x can be only 4. There is no other value of x possible for which x plus 5 will be equal to 9. X can only be 4, right? Yes, x can only be 4. If x plus 5 equals to 9, then x can only be 4. But if I ask you that denote me the outcome that can occur if a dice is being thrown. Now if a dice is being thrown, there can be 6 outcomes, 1, 2, 3, 4, 5 and 6. Now can you surely say that the outcome that will come will be 3 or the outcome that will come will be 5? Obviously not, you can't surely say that. But you can say a probability to each outcome. You can assign a probability to each outcome. You can say that the probability of outcome 1 appearing when a dice is being thrown is equal to 1 by 6. You can say that a probability of a dice of 2 appearing when a dice is being thrown is 1 by 6. You can say that when a dice is being thrown, the probability of getting 3 is 1 by 6. So you can't surely say that 3 will occur or 5 will occur, but you can assign a probability to each of the value being occurred, right? So the first case that I discussed, that was x plus 5 equals to 9, where x equals to 4 only possible, right? Here this x is called algebraic variable, where x can only have one value. That is not possible that x have multiple values, right? And the later case that we have discussed is the dice throw. In the case of dice throw, if we try to denote it, then this is the case of random variable, where you can't say surely that this value will come or this is the value of x. You can assign a probability to each value of x. What are the values of x? 1, 2, 3, 4, 5 and 6. And you can assign a probability to each value of x. That is, the probability of x coming as 1 is 1 by 6, x coming as 2 is 1 by 6, x coming as 3 is 1 by 6, and like that, right? So in case of random variable, it can't be said that it has a definite value. In that place we have to say that that variable has definite value with corresponding probabilities. That means we can't say that it will come as a definite value, but we can say that a value coming has a probability, right? Just in the case of dice throw. So ui is a random variable. That means you can't say that ui can have a fixed value, but you can say a probability for each value of ui. You can't say that ui or error term has a fixed value, but you can say a probability for each value of ui. Okay, and each random variable have a probability distribution. If you are not aware with the concepts of probability distribution, then this video will be very difficult for you to understand, but still I am going to explain a little bit about probability distribution. So if we write the outcomes of a random variable and the probabilities in the form of list, that means on the first row we are writing the outcomes of the random variable, that is 1, 2, 3, 4, 5 and 6, and on the second row we are writing the corresponding probabilities of each outcome, right? That is 1 by 6 for each case, obviously. So this list of outcomes of random variables and their probabilities, this list is called probability distribution, right? Here this ui or error term, which is a random variable, has a probability distribution. Obviously each of the random variables have their own probability distribution, because they don't have a, in case of every random variable you can't say a fixed value, you have to say the probability of each value, right? What will be the probability of each value, you have to say that. Now expectation of ui, okay, in case of random variable we will take expectation. That you have to remember always, if the variable is not random, you will find out the mean. If the variable is random, you will find out the expectation. Why are we taking expectation in case of random variables? Because random variables are not observable. Okay, random variables are not observable, and we have probabilities of the values. We don't have fixed values of random variables, so that's why we have to take expectation of random variables. Now xi is not depending upon ui, right? Xi is completely independent and it is completely free from each of other things, right? So xi is non-random or non-stochastic. Okay, stochastic means random, non-stochastic means non-random. In case of non-random variable, we will take mean, as I have said, x bar will be the case. Yi is a random variable. Why yi is a random variable? Yi is a dependent variable, obviously. But what is the nature of yi? Is it a random or non-random? It is a random. Why? Yi is depending upon ui, and ui is what? Ui is a random variable. So if yi is depending upon something which is random, then yi is also becoming random, right? So yi is also becoming random variable because it is depending upon a random variable called ui. So that's how yi is a random variable, and yi is depending on ui, that's why yi is a random variable. So obviously yi will also have a probability distribution, just like in each case each random variable has a probability distribution. So yi will also have a probability distribution. Well, let me just zoom in. It is the same page probably now. Now, as I have told about the story, that this is the equation denoting d equals to alpha plus beta p plus ui. The next pages are quite clear. In this page we have a little bit problem of writing. The visibility is a little bit of concerning in this page, but from the next page it will be clear. Although it is visible, you will be able to understand. In the case of demand function, we can represent it as d equals to alpha plus beta p plus ui. Now if we find out the slope, how to find out the slope? You have to take the derivative of the function with respect to the independent variable. If you take the derivative of both sides with respect to the independent variable, then you will find out the slope. I have taken the derivative and I have found the slope, which is beta. Now beta will be a numeric value, right? It will be a number, but we still haven't assigned any number, but it will have a number. Now the case is, if the value of beta is positive, that means our slope is positive. But law of demand tells us that our slope should be negative, because as price increases, demand decreases. So when beta is negative, that means our slope will be negative. So how to check whether our beta is negative or positive? How to check this? So for that we can take the help of statistical tests. and I will come to those things. Well, suppose A and B has taken data from the market and tried to explain the relationship between price and demand. Think from the beginning. You have learned many things in economics. The first thing that you learned in economics was probably the law of demand, and in the law of demand you learned that there is a negative relationship between law of demand, right, between price and the quantity demand. Now you want to test it. Theoretically you have read it, but you want to test it practically. So for that you have went to the market and you have taken the values, or you have taken the observations of the variables called price and demand. So from the observation, after running a regression, what is regression? I will tell that. I will come to all of these things. For now, just understand. A has found out the equation that D equals to 2 minus 0.5p, and B has found out the equation of demand function as D equals to 3 plus 0.1p. Now the slope of the demand function found by A is negative. That is very good, right? Because that means if the price increases, demand will fall, as we have read. Hooray! But what happens to B? B is showing that if price increases, demand is falling. So that means the demand is increasing, right? That means B's result is showing that the slope is positive. So that means if price increases, is really demand increasing? Well, the results show that, right? The data on which the survey was done, the result shows that thing simply. So now the case is how to check that whether A is correct or B is correct. For that we have to check that whose slope is correct. Is our A or is our B? Is A correct which is slope which is negative, or is B correct which is slope which is positive? So for that we have to check the statistical significance of the slope, right? So for that we will do some statistical hypothesis testing. If you don't understand this part, it is completely okay. I will make a detailed video on hypothesis testing, of which is a very important part of econometrics. Then you will completely understand it. So there are two hypotheses we are setting. That A is 0, that is a null hypothesis. It tells that beta equals to 0. That means there is no relationship between price and demand. And H1, that is the alternative hypothesis, which tells us that beta is less than 0. That means there is a negative relationship between price and demand, and we will find out the T statistic, that is beta minus beta hat divided by standard error of beta hat. Okay. Actually the formula was beta hat minus beta. Here the formula is written in inverse way actually, but it should be beta hat minus beta. Although beta is taken the value of null hypothesis, which will be 0, so we will put 0 in place of beta, and we will do the hypothesis testing. Detailed description of this will come in the later parts of the video. For now we are just skipping that, and we will come to these portions of hypothesis testing in a very descriptive way in the later classes, right? Hypothesis testing is a very important part of econometrics, and I will come to that. Now just tell me that, just look into this equation, yi equals to 7 minus 0.1 xi. Now this is the value of, if we want to find out the slope, we will take the partial derivative of the dependent variable with respect to independent variable, and you will find out that the slope is minus 0.1. Now what is the interpretation of slope? That is also important to know. Well, interpretation of slope is when the independent variable increases by 1 unit, or when the independent variable changes by 1 unit. The dependent variable will be changing by the amount given in the slope. Like here, if the independent variable x changes by 1 unit, the dependent variable y will change by 0.1 unit. To be more precise, if x increases by 1 unit, slope, the sign of the slope is negative, right? So if x increases by 1 unit, y, or the dependent variable, will decrease by 1 unit, 0.1 unit. Why is it decreasing but not it increasing? It is decreasing because the sign of the slope is negative, right? This is the equation of a two variable linear regression model. In case of population, here the equation is yi equals to alpha plus beta xi plus ui. Here I belongs from, here I belongs, let me just, here I belongs from small, I belongs to 1, from 1 to small n. Okay, let me just zoom it again. If I belongs to 1 to capital N, that means it is a population regression function, and if I belongs to 1 to small n, that means it is a small or sample regression function. Okay, so this is just denoting the sample size. So obviously we know that sample is denoted by small n and population is denoted by capital N. So if I belongs from 1 to small n, then that is sample regression function, and if I belongs from from 1 to capital N, then that is population regression function, and the other parts here, that is y, x, and alpha, beta, and y, I have already discussed about this part. Right, now we are going to the next page, which is blank. We are going to this page. Now this is the important concept of econometrics that is being started here, from here. Tell me one thing. You have different values of x and you have different values of y. We have multiple observations of x and y, right? If we create a scatter plot from that pairs of observations, I have multiple observations of x, I have multiple observations of y, and if I want to create a scatter plot from those observations, so there will be multiple scatter plots in our graph, as you can see. Now if I want to fit a very proper line that will be going from the scatter plots, from the points of scatter plots, so then that line can be like this. But now the question is, there can be multiple lines which I can draw. There can be multiple lines which I can draw from these points of scatter plots. How to select that which line is going to be the best line, or which line we have to take and which line we don't have to take? So for that you have to understand one thing. As you can see, there are multiple points of, when we have done the scatter plot, there are multiple points. Now the line which will have the minimum distance from all the points, the line which have the minimum distance from all the points of the scatter plot will be taken as the best fit line, and we will draw and take only that line, and we will remove all the other lines. It is true, you might be thinking that, sir, why are we not taking all the lines, or why are we not taking any other line? Well, we are supposed to take only one line. Let me be very clear, we are supposed to take only one line. But why are we taking this line? Why are we not taking any other line? Well, this line have the minimum distance from all the points which were being created by the pairs of observation of x and y, or by the scatter plot of x and y. We have done the scatter plot, we have multiple points. This line has the minimum difference, or this line has the minimum difference from all the points or from all the scatter plots. That's why we are taking this line. Okay, so just look into this. It is written here, if we plot the observations on the basis of the scatter diagram and draw on an average mean line, this on an average mean line is nothing but it is called a best fit line. And what is the purpose of drawing this best fit line, or how to draw this best fit line? Take this best fit line in a way so that the distance of all the points from the best fit line is minimum. Okay, so this line has an equation, every line has an equation, you know that, we read it in if you are reading this level of econometrics, you have the very basic idea about it, that every line has an equation. The form of equation is nothing but y equals to mx plus c, where m is the slope, c is the y-intercept, y is the dependent variable, and x is the independent variable. Here we are not writing it in the form of y equals to mx plus c, we are writing it in the form of y hat equals to alpha hat plus beta hat xi. Here x is nothing but independent variable, y is dependent variable, alpha hat and beta hat are the estimated parameters. Okay, now beta hat is also the slope and alpha hat is also the y-intercept, just like m and c in the case of y equals to mx plus c. Now there are several, we have to calculate this alpha and beta. We have to calculate this alpha hat and beta hat. What is alpha hat? It is the y-intercept. And what is beta hat? It is the slope. Now let me just clear one thing. What is that one thing? That when you are taking this line, which has the minimum distance from all the points, when you are taking this line, how this line is determined? This line have only two components. Every line has only two components, right? One is the y-intercept, which is the alpha hat, and another one is the slope of the line, right? That is beta hat. So you have to actually find out these two things to find out this baseline. For finding out this baseline, you have to find out these two components only. One is the y-intercept, which is alpha hat, and another one is the slope, which is beta hat. Okay, so if we plot the observations, we have to find out this alpha hat and beta hat, because this alpha hat and beta hat will give us the best fit line, which has the minimum distance from all the points of scatter plot. What is alpha hat and beta hat? It is this intercept and slope, and every line is composed by their intercepts and slopes, right? Now there are several methods to calculate alpha hat and beta hat. Maximum likelihood estimation, ordinary least square estimation, like that. We are going to take the help of ordinary least square estimation method. So just we are going to take OLS method. Now the concept of OLS method is very simple. So in the OLS method we are going to take the errors. Now what are errors? If you see, there were multiple scatter points which are not on the line. Several scatter points are on the line, that's why we have been successfully created the line, right? But there are multiple scatter plots or multiple scatter points which are not on the line. So they are deviating, right? They are deviating from actual line, right? This deviation is represented as error term, as we actually know. So error term is nothing but actual minus observed. Okay, what is observed? Observed is the value on this line, right? And what is actual? Actual is this data point. Suppose for this data point, this is the actual. This is the actual y, and this is the observed y, right? Let me be very clear with an example. Suppose you have expected that in an exam you will get 42 marks. So this was your expectation about the exam, that you will get 42 marks, right? Now when the exam occurred, what you actually got, you got only 40. Right, what have I told here? You have got only 40. So this difference between your actual marks, or suppose you have got 44, in your exam you got 44, so you got 2 marks more than your expectation, right? So actual minus observed. What is actual? 44 which you got. What was observed? What was expected? What was expected? Expected was 42. So this 2 you got more. This 2 is nothing but error term. In terms of statistics, how can we represent this error term? Well, let me just erase it. We can represent it as actual minus estimated. How? Let me just explain it with only 2 points. Suppose this is a line which is being created by multiple scatter points. There are some other scatter points which are around the line, but we are not going to draw these scatter points because for the simplicity of explanation I am just taking this scatter point. Now what was the actual data? The actual data is saying that this is the value of y and this is the value of x, right? But the line is telling that the data is on this point and corresponding of this x. So this is what? This is our what? Actual or observed data? This is our actual or estimated data? This is our estimated data. Why is it estimated data? Because from the line we have estimated it, right? And what is actual? Actual is this. So there is a difference of y. If this is 0 and this is 2 and this is 4, then what is the difference of y? 4 minus 2. There is 2 units of difference in y. This difference of actual y and observed y, this is what? This is actual y, and this is estimated y or observed y, y hat. Right? So this difference between actual and estimated y is known as error term or UI. In the process of called OLS, it's a very famous procedure. In this process we are going to take the help of this EI. We are going to square it at first. Okay, so as you can see, I have squared it on the both sides. Then we are going to take the summation, and as you can see, I have taken the summation. This should be here also. This summation should be here also. So I have taken the summation, I have squared it, and then I have taken the summation. Now I have to minimize this sum. So what is this sum made of? This sum is made up of squared errors, right? We have taken the error, we have squared it, and after squaring it we have find out the sum. So this sum is made up of squared errors, right? So we are minimizing the sum of or the summation of squared errors. So what is the condition of minimization? If you are reading this level of econometrics, you must be aware that there are two conditions of minimization. First order condition equals to 0 and second order condition is less than 0. So we are going to take the partial derivatives and see whether the first order conditions are 0 and second order conditions are less than 0 or not. So what is the requirement of minimization? It is given here. First order condition is 0 and second order condition is less than 0. Now, so for minimization we are going to take S, and in the place of yi I have put in alpha hat plus beta hat xi, because this was the equation. What was our equation on the line? That was y hat equals to alpha hat plus beta hat xi. So in the place of yi hat I have put y alpha hat minus beta hat xi. What is the first order condition? That is, if we take the partial derivative of this S with respect to the parameter called alpha hat, we will get 0, and if we take the partial derivative of the S with respect to beta hat, we will get 0. So we will do the partial derivative and set it as equals to 0, right? Now when you are doing the partial derivative of S with respect to alpha, what will happen? As you can see, when you are doing partial derivative with respect to alpha, let me just zoom in a bit. At first, what is happening? 2 is coming in the base. 2 is from the coming, 2 is from power, 2 is becoming the base, right? Now n minus 1 will be 1. So I hope you guys know this basic level of derivative. So in the power we have 2 minus 1, so that is 1, so we don't have anything. Now as we are doing partial derivative, so we will find out where alpha hat is present, and we will do the derivative of that part again. So we will do the derivative of minus alpha hat again, and that will be equal to minus 1. So that's why we are writing it as 2 into summation of yi minus alpha hat minus beta hat xi into minus of 1. And we are setting it up as equals to 0. Similarly, in the second part, we are just doing the derivative with respect to beta hat. The same thing again, 2 comes from power to base, and we are keeping the remaining thing as it is. In the next part, as it is partial derivative, so we are finding where beta hat is present. Here beta hat is present with minus beta hat xi, this term. So if we do the derivative of this term with respect to beta hat, we will get only minus xi. Okay, so it is kept here. We are setting it as equals to 0, right? Now if we simplify these two equations, the first equation, minus 2 will be wiped out. Okay, just multiply minus 1 is 2, that will be minus 2, take it on the right hand side, it will be 0. So minus 2 will be wiped out, and we will have summation yi equals to alpha hat plus beta hat xi minus beta hat xi. Now just think, if we take the summation with yi and alpha hat and beta hat xi, what will happen? At first it will become summation yi. What will happen to this? If we take summation with a parameter, then that will become n alpha. How? If you are taking summation of alpha hat, that means you are adding alpha hat for n times, right? If we take common alpha hat from this, then it will be 1 plus 1 plus 1 plus 1, and it will be continuing. The sum of 1s is termed as n, because the sum of 1 will be nothing but n, so it will become n alpha hat. So in this way, summation of alpha hat will become n alpha hat and beta hat xi. Here beta hat will not be into the summation, because when a parameter is assigned as the coefficient of a variable, then the parameter does not take summation. But if the parameter is only present, then it will take summation and it will be converted into n alpha, right? So beta hat will not take summation. Summation will be taken with only, sorry, I was there, sorry. Summation will be taken with only xi. So it will be beta hat summation xi. So it will be summation yi minus n into alpha hat minus beta hat into summation xi. If we take this n alpha and beta hat summation xi on the right hand side, it will become plus n alpha and plus beta hat xi, because there was only 0 on the right hand side. So we have summation yi equals to n alpha plus beta hat into summation xi. And in case of second equation, we are going to have we are going to multiply it with, at first this 2 will not be present, 2 is not valid, it is not required. If we multiply it with 0, it will be 0. But this xi minus xi will be divided in with, okay, minus 1 is also not required. This minus will be multiplied with 2 and it will be taken on the right hand side and it will be 0. So we have only xi. Now if we multiply this xi with yi and xi with alpha hat and xi with beta hat xi, it will be xi yi, alpha hat xi and beta hat xi square. If we take the summation, it will be summation xi yi, summation is all of the terms, it will be summation xi yi, and then it will be alpha hat summation xi and beta hat summation xi square. So as you can see here, that is the thing. Just we have taken the summation xi yi on the left hand side, we have kept it, and this alpha hat summation xi and beta hat summation xi square is being kept on the right hand side. So that is what is written here. Now what will we do? We will take the help of matrix approach to find out the equation of CLRM. Okay, these 3 and 4, these two equations are the normal equations of CLRM. Let me show it again. I forgot to tell it. These 3 and 4 equations. These 3 and 4. These 3 and 4 equations. These two equations are called the normal equations of the CLRM model. Now, as I am telling here that we are going to take the help of matrix approach from here. You can also not take matrix approach, but still matrix approach is a very famous way and it is very easy to use. 3 and 4 are the normal equations, as we have said. After making matrix from 3 and 4, what will you do? You will actually take, as you can see on the left hand side, on this portion you have actually taken, let me just show it. This part on the left hand side of the matrix, or on the left side matrix, we have taken this part, these two elements, and in the next matrix we are going to take the coefficients of alpha hat and beta hat. Just look into this, where it is, probably this, no, this. As you can see, we have taken the coefficients of alpha hat and beta hat in the next matrix, and in the last matrix we have taken alpha hat and beta hat. Okay, if you want to see it again, you can pause it and go back to the video and can see it. For finding beta hat, we have to this matrix which is in the middle, that is n summation xi summation xi summation xi square, this matrix will be our denominator. Okay, for finding beta hat, this matrix will be our denominator, or more precisely to be said, said if we find out the cross product of this matrix, then this matrix, if we find out the cross product of this matrix, then this matrix will be surely our denominator in that case. What will be the cross product? That will be n into summation xi square minus summation xi square. Okay, so that's how we have to keep it. So by solving determinants, we can get it as beta hat equals to n into summation yi xi minus summation xi yi divided by n into summation xi square minus summation xi whole square. If we modify this formula, it will become summation small xi small yi divided by summation xi square. What is summation small xi yi? Well, summation, not summation, well, small xi means capital Xi minus x bar, and small yi means capital yi minus y bar. There is no more explanation between this. It has a little bit extended proof, but I am not interested in that, because that is, knowing a lot of proofs this will not help you, but knowing the concepts well will help you very much. Alright, so by dividing this equation 3 by n, if we divide the equation 3 by n, as you can see, which was our equation 3. By dividing the equation 3, this is 11th page and this is the 10th page. No, this is not the equation 3, this is the 9th page. As you can see here, this is the equation 3. If we divide this equation with n, what will happen? Summation y bar will turn into y bar, n into alpha will turn out alpha bar, and beta hat summation xi, here beta hat will be unaffected, but summation xi will be turned into x bar. Okay, so that's how we can actually find out. So here it is also done. We have found out the value of alpha hat from here. Y bar equals to alpha hat plus beta hat xi, as I have told. If we take the beta hat x bar on the left hand side, we will have the value of alpha hat, which is y bar minus beta hat x bar. In this way we can find out the value of alpha hat and beta hat in the memorial, in the previous part. Okay, now from the next class we are going to discuss about the blue properties of OLS estimation. Till now, goodbye.